Hello, people, and welcome to the Sleepy Science Lab. Tonight, we drift gently into one of the deepest mysteries in all of physics, the enigma of light itself. Light isn't made of matter, yet it carries pure energy through the vast emptiness of space. It moves with unchanging precision, constant, unwavering, no matter who observes it or how fast they're moving. Every breathtaking image of a distant galaxy, every theory of relativity, every glimpse into the universe's earliest moments after the Big Bang begins with light. It is our messenger and our measure, revealing how the universe behaves and how time itself unfolds. If you enjoy these quiet explorations, consider liking, subscribing, or sharing a thought below. It helps more curious, sleepy souls find their way here, one dreamer at a time. Now, take a slow breath. Let your eyes grow heavy, and let the mystery of light cradle your thoughts. Let's begin. The dual nature of light. Light is one of nature's greatest paradoxes. It exists as both a wave and a particle, a phenomenon that defies the limits of ordinary understanding. In some experiments, light behaves like ripples spreading across water, overlapping to create delicate interference patterns, the hallmark of waves. Yet, in others, it arrives as tiny, individual bursts of energy, photons, striking one by one like microscopic bullets. Both realities are true. Light wears two faces, revealing whichever one we ask to see. When it moves freely, it flows like a wave, carrying energy across space. But when it meets matter, it interacts as a discrete particle. This dual identity isn't unique to light. It extends to all things at the smallest scales, electrons, atoms, even molecules. The quantum world reminds us that reality isn't fixed, but shaped by probabilities, unfolding differently depending on how we choose to observe it. Color, the music of light. Every color we perceive is a different frequency of the same continuous energy. Red, green, blue, these are not separate entities, but vibrations at different speeds. Red light oscillates more slowly, violet light more rapidly. Together, they form the narrow band we call the visible spectrum, a tiny sliver of a much larger electromagnetic ocean. Beyond red lies infrared light, which we feel as warmth. Beyond violet is ultraviolet, energetic enough to burn our skin. Our eyes evolved to sense only this limited range, the portion most abundant in sunlight that reaches Earth. Every glow, every reflection, every shimmer you see is part of this vast symphony of oscillations, differing only in frequency. Beyond what our eyes can see stretches an endless continuum of invisible light, from radio waves to gamma rays, all part of the same unbroken field of energy. The journey of sunlight. Every morning, sunlight reaches Earth after a journey of roughly 8 minutes, racing through the vacuum of space at the fastest speed nature allows. But the story of that light began long before it touched our world. Deep within the sun's core, hydrogen atoms fuse to form helium, releasing immense energy in the process. The photons born there don't escape immediately. They're absorbed and re-emitted countless times, bouncing through dense layers of plasma in a journey that can take hundreds of thousands of years. Only when they reach the sun's surface are they free to travel outward. Some of those photons eventually cross the gulf of space to warm your skin. When you feel the gentle heat of sunlight, you're sensing the final step of a journey that began inside a star. Energy created ages ago, now whispering across the cosmos. Light as a time machine. When we gaze at the night sky, we aren't seeing the universe as it is, but as it was. Light takes time to travel, so every star is a message from the past. The glow of a nearby star began its journey years ago. The faint smudge of a distant galaxy began billions of years in the past, when the cosmos was still young. Telescopes act as time machines, gathering these ancient photons and allowing us to witness the birth and evolution of stars, galaxies, and entire worlds long gone. The night sky, then, is not merely a view of space, it's a window into deep cosmic history. The speed limit of the universe. Nothing travels faster than light in a vacuum. This isn't just a rule, it's a foundation of reality. Every event, every exchange of energy, every signal of cause and effect must obey this cosmic limit. As objects move closer to light speed, time slows down for them, and distances seem to contract. To reach or exceed that speed would require infinite energy, something no known physics allows. This constancy is what led to Einstein's revolutionary theory of relativity, uniting space and time into one cosmic fabric. Light doesn't just move through the universe, it defines how the universe itself moves. When light slows down. In the vacuum of space, light races at its full speed. But as it passes through materials like glass, water, or air, it slows slightly. Inside these mediums, photons are repeatedly absorbed and re-emitted by atoms, creating tiny delays. Under extraordinary laboratory conditions, scientists have even slowed light to the pace of a slow walk and, astonishingly, stopped it entirely by storing its energy pattern within ultra-cold atoms. In these moments, light doesn't vanish, it simply transfers its information into matter, waiting to be released again. These discoveries reveal how deeply intertwined light and matter are, laying the groundwork for quantum memory systems, lasers, and communication technologies of the future. The hidden universe of light. Human vision captures only a narrow slice of the electromagnetic spectrum, from red to violet. But beyond that lies a hidden cosmos. Infrared radiation, though invisible, radiates warmth. Ultraviolet light, though unseen, can burn skin and power chemical reactions. Many animals navigate this unseen world with ease. Bees follow ultraviolet markings on flowers that guide them to nectar. Certain snakes detect infrared heat from prey in total darkness. With modern sensors and cameras, we too have extended our sight beyond biology, seeing heat signatures, cosmic radiation, and the fingerprints of atoms light years away. Through technology, the invisible becomes visible, revealing the universe's hidden architecture, the oldest light in existence. Long ago, when the universe was young, light couldn't travel freely. The cosmos was a dense fog of charged particles, trapping radiation within it. Then, as the universe cooled, atoms formed and light was finally released, beginning its endless journey across space. That ancient glow still surrounds us today, as the cosmic microwave background, the oldest light we can observe. Though invisible to human eyes, it can be detected as faint microwaves coming from every direction, carrying imprints of the first structures that would one day form galaxies. By studying this relict light, scientists learn the age, shape, and composition of the universe, listening to the faint echo of creation itself. The colors of sunset. When the sun dips toward the horizon, its light travels through more of Earth's atmosphere. Along the way, the shorter blue wavelengths scatter out of view, leaving behind the rich reds, oranges, and golds of twilight. Dust, moisture, and air molecules shape each sunset uniquely, the bending of light, refraction, and illusion. Light doesn't always travel in straight lines. When it crosses from air into water, it slows down and bends, a phenomenon known as refraction. This simple effect creates an entire world of visual magic. It's the reason a straight straw looks bent at the surface of a glass, and why fish beneath the water seem closer than they really are. Refraction is also what allows your eyes to focus, what lets glasses and microscopes magnify the world, and what gives cameras their sharp vision. Every material bends light differently, depending on how its internal structure delays each wave, a property known as its refractive index. The angle at which light enters a surface also changes the degree of bending, which is why the view across a shallow lake can appear so distorted. Prisms use refraction to split white light into rainbows, each color bending at a slightly different angle. From the sparkle of a diamond to the shimmer of a mirage on a hot road, refraction is one elegant principle expressing itself in countless illusions of everyday life. The secret shape of rainbows. What we see as an arch in the sky is actually only half of a perfect circle of color. A rainbow forms when countless raindrops act together like tiny prisms, bending sunlight, reflecting it inside, and bending it again as it exits. Because the ground usually blocks the lower half, we only see a semicircle. But from a mountain or airplane, the entire glowing ring can appear, your own shadow perfectly centered within it. No two people ever see the same rainbow. Each one is a personal alignment between your eyes, the sun, and the raindrops before you. Even fog, waterfall spray, or garden mist can create miniature versions of this breathtaking geometry. A rainbow is a quiet reminder that perspective and physics are always dancing together. Every raindrop, a tiny prism. Each falling droplet performs a beautiful optical experiment. As sunlight enters, it slows, bends, reflects off the inner surface, and bends again as it leaves, separating into colors because each wavelength deflects slightly differently. Larger drops create sharper, more vivid bands of color. Smaller ones paint softer, pastel hues. Wind and air distort the perfect spheres, adding texture and depth to the arc. The rainbow we see is not a single object, but the sum of countless droplets, each sending its own narrow beam of colored light directly to your eyes. Step a few feet in any direction, and a new set of droplets forms your rainbow anew. The same principle paints the shimmering bows in waterfalls, ocean spray, and fountain mist. The sky's grand spectacle is nothing more than millions of tiny prisms at work, together creating beauty from physics. White light, all colors in harmony. White light is not the absence of color, but the perfect balance of every color at once. A prism or a thin soap film can reveal this by splitting it into a continuous spectrum, red to violet, each hue shining in harmony. Our eyes perceive white when all three types of cone cells are stimulated equally. But not all white is the same. Sunlight has an even blend across all wavelengths, while artificial lights lean warmer or cooler, depending on their spectral mix. Photographers and filmmakers carefully balance these tones so that skin, fabric, and shadow look natural under changing illumination. Astronomers use the same principle to read the fingerprints of stars, studying subtle shifts in starlight to uncover temperature, chemistry, and motion. Far from being plain, white is a symphony, a chord of light resonating across the visible spectrum. Crystals, nature's architects of light. Inside every crystal lies an intricate order that guides light like a maze of mirrors. Some minerals split a single beam into two paths, traveling at different speeds, a property known as birefringence. Hold a clear calcite crystal over text, and the words appear doubled, dancing as you rotate it. Gemstones sparkle for the same reason. Their facets bend and bounce light in precise patterns, sending narrow beams outward in flashes of brilliance. In the upper atmosphere, ice crystals act like miniature prisms too, forming halos, arcs, and mock suns that decorate the sky. Scientists use carefully engineered crystals to filter polarizations, tune laser beams, and manipulate light with incredible precision. Whether in jewelry, clouds, or laboratories, crystals show us how order and beauty arise from atoms repeating in perfect rhythm, guiding light along invisible, geometric pathways. The narrow window of human sight. The human eye perceives only a thin ribbon of the electromagnetic spectrum, a small stretch from deep red to violet. Beyond red lies the infrared, microwaves, and radio waves. Beyond violet are ultraviolet, X-rays, and gamma rays. Our biological window was shaped by sunlight and Earth's atmosphere, tuned to the wavelengths that pass through air and reflect from leaves, skin, and stone. But with technology, we've expanded our reach. Infrared cameras let us see heat and peer through cosmic dust. Ultraviolet detectors reveal glowing minerals and biological fluorescence. Radio telescopes map cold gas drifting between stars, and X-ray and gamma-ray observatories catch the violent outbursts near black holes and neutron stars. Each band of light is a different dialect in the same universal language. Together, they tell the full story of the cosmos. Human eyes are a wondrous beginning, but instruments have shown us that light is far richer and more complex than we ever imagined. Bioluminescence, life that glows. In the deep ocean, where sunlight never reaches, darkness is not the absence of light, it's the canvas upon which life creates its own. Many marine organisms produce light through bioluminescence, a chemical reaction that releases energy as a gentle glow. Anglerfish wave living lanterns to lure prey. Jellyfish pulse with halos of soft light to confuse predators or attract mates. Shrimp release clouds of sparkling light to vanish into the dark. Even microscopic plankton flash when disturbed, tracing glowing trails along the waves. These lights are often blue or green, colors that travel best through seawater, and are remarkably efficient, converting chemical energy into light with almost no heat. Scientists have adapted these glowing reactions as tools in medicine and genetics, using faint bioluminescent signals to reveal cellular activity. In the eternal night, light becomes life's most versatile tool for communication, camouflage, and survival. Fireflies, lanterns of the land. On warm summer nights, fireflies flicker across meadows like living stars. Their light is produced by a chemical reaction between oxygen and a compound called luciferin, controlled by enzymes that let them flash with exquisite timing. Each pattern of light is a species-specific signal, a language of attraction, rhythm, and recognition. The glow is so efficient that almost no energy is lost as heat, a perfect example of what scientists call cold light.
Researchers use the same chemistry to create biological markers that glow when certain genes activate or when molecules appear inside living cells. Even modern LED designs have borrowed from firefly biology to extract light more effectively. Fireflies also serve as indicators of environmental health. Their life cycles depend on clean water, stable habitats, and healthy ecosystems. Each tiny flash is a link between physics, ecology, and evolution, a pulse of light that bridges science and wonder. The glowing seas. Sometimes the ocean itself seems to come alive. On certain nights, waves shimmer and foam with ethereal blue-green light, the work of millions of tiny plankton responding to motion. A boat's wake, a swimmer's hand, or the curl of a breaking wave sets them aglow, releasing brief flashes of bioluminescence. This glow can startle predators or attract other creatures, an ancient defense written in light. Warm, nutrient-rich waters make these glowing blooms more common, but they can appear almost anywhere. Long exposure photographs reveal swirling calligraphy on the surface, strokes of light drawn by living cells. What feels otherworldly is simply life interacting with physics, the sea writing poetry in light, one luminous letter at a time. Auroras, the sky's electric dance. High above the poles, the heavens ignite in ribbons of color. Auroras form when charged particles from the sun ride Earth's magnetic field and collide with atoms in the upper atmosphere. Oxygen glows.
The reason the sky appears blue isn't magic. It's science written in the air itself. Human eyes are more sensitive to blue than violet, so when sunlight scatters through the atmosphere, it paints the heavens in a soft blue dome. Near the horizon, where light travels through a thicker slice of air, the scattered path favors gentler, paler shades. At sunrise and sunset, that same scattering changes character. The sun's rays lose much of their short blue light, leaving behind the deeper reds and golds that bathe the world in warmth. Even distant mountains wear a soft bluish haze for the same reason. Layers of air bend and scatter the light, turning distance into poetry. It's not pigment that colors the sky, but geometry and scale, quietly working together to repaint our world every single day. The moon, on the other hand, glows only by borrowed light. It has no radiance of its own. Its dusty surface merely reflects sunlight in all directions, like a cosmic mirror made of ancient stone. Only a small fraction of that light reaches Earth, yet in the deep black of space, it shines brilliantly. As the moon orbits, we see shifting portions of its sunlit half, the familiar phases that guide our calendars and our tides. Along the dividing line between light and dark, mountains cast long shadows that reveal the moon's rugged terrain. Subtle color variations hint at minerals left from volcanic plains and ancient impacts. And during a total lunar eclipse, Earth's atmosphere bends sunlight around its edges, bathing the moon in a deep copper-red glow, a global sunset projected onto another world. For millennia, this borrowed light has guided sailors, storytellers, and scientists alike, transforming a silent rock into humanity's luminous companion. Every hour of every day, sunlight powers the machinery of life. Through photosynthesis, plants capture that energy and weave it into sugars, the foundation of every food web on Earth. Herbivores eat the plants, predators hunt the herbivores, and decomposers recycle what's left back into the soil. Sunlight drives not just life, but the wind, the rain, and the rhythms of the planet. Even fossil fuels are, in truth, ancient sunlight, energy captured eons ago and stored beneath the ground. Our bodies, too, are synchronized to light. Biological clocks rise and rest with the sun, guiding sleep, growth and migration across species. Seasons change with the length of the day, signaling flowers to bloom and leaves to fall. From the oxygen we breathe to the crops we harvest, a single star sustains the endless dance of life, its steady light underwriting every heartbeat on this planet. But light does more than nourish life. It defines the speed limit of the universe itself. In the emptiness of space, light always travels at one fixed speed, an ultimate constant that nothing can surpass. Whether it's emitted by a moving star or measured by an observer at rest, its pace never changes. To make that possible, space and time themselves must bend and adjust, ensuring the rules of physics remain intact. As an object nears light speed, time slows down for it and distances compress in the direction of travel. Experiments with fast-moving particles and atomic clocks confirm these astonishing truths. This cosmic speed limit preserves cause and effect, keeping the universe logical and orderly, preventing paradoxes from tearing reality apart. Light, then, is not just a beam, it's the backbone of existence, setting the tempo for every exchange of energy and information. In the presence of gravity, light reshapes time and space. Einstein's theory of relativity reveals that measurements of distance and duration depend on motion and gravity's pull. Because the speed of light must stay constant, the fabric of space-time flexes to obey that rule. Gravity bends light and slows time, effects so subtle that satellites must account for them to keep GPS navigation precise. Astronomers use these distortions to weigh galaxies, track black holes, and map the expanding universe. These warps aren't abstract math, they're tools we use every day. Light is both messenger and measure, showing us how gravity molds the very stage on which the universe unfolds. A photon, the smallest particle of light, has no mass, yet it carries energy and momentum. Because of that, photons always move at light speed and never rest. When they strike matter, they transfer pressure, a gentle push powerful enough, over time, to steer comet tails, sweep cosmic dust, or propel reflective sails across space. Photons can also twist, polarize, and carry complex structures, expanding the ways we encode information in beams of light. In quantum experiments, single photons can interfere with themselves or become entangled, hinting that information itself can travel as delicately woven threads of energy. Every glimmer, every sparkle, every ray of sunshine is a river of these messengers, tiny packets bridging the void between stars. Remarkably, a single photon can awaken the human eye. Within the retina, rod cells hold light-sensitive molecules that change shape when struck by one photon. That microscopic shift triggers a cascade of reactions, amplifying the signal until it becomes an electrical impulse sent to the brain. Under controlled conditions, humans can detect flashes of just one quantum of light, proof that our vision evolved to thrive in the faintest twilight, when survival depended on catching even the smallest glint of motion. That photon might have crossed billions of miles or reflected off a nearby wall, but its arrival becomes a moment of awareness, a meeting of energy and perception where the universe literally comes alive inside the mind. But where human sight ends, evolution continues. Owls, cats, and sharks have developed eyes that can read the night like an open book. Their pupils widen to capture every stray photon, and reflective layers behind their retinas give each particle of light a second chance to be seen. Deep sea fish wield enormous eyes tuned to the blue-green glow of bioluminescence, while snakes and beetles can sense the infrared warmth of living bodies. Even moths and other night flyers navigate by subtle polarization patterns in starlight. What we call darkness is, for them, a vivid world, a landscape alive with movement, edges, and shapes painted by the faintest whispers of light. And when we look up,
The Milky Way reminds us that light connects it all. Far from city lamps, a soft river of stars stretches across the night sky. Not a cloud, but the combined glow of billions of distant suns. Each one, too faint to see alone, joins with countless others to form that silvery band. Dust between the stars shapes it further, tracing the spiral arms of our galaxy with shadowed grace. Every photon that reaches us began its journey thousands of years ago, crossing interstellar space before landing gently in your eyes. In that instant, you're witnessing the history of our galactic home, a luminous cross-section of the cosmos itself. Light needs no medium to travel. Unlike sound, which ripples through air or water, light is entirely self-sufficient, a dance between electric and magnetic fields that sustain each other as they move. It doesn't need to hitch a ride on matter. It is its own traveler. Early scientists once imagined an invisible ether filling space, but experiments proved otherwise. Light moves freely through the void, connecting stars, planets, and galaxies in silence. Every sunrise and every starlit night prove that waves can cross emptiness, and that the universe itself is woven together by light's unbroken thread. Mirrors, meanwhile, reveal light's symmetry. They obey a simple rule: the angle in equals the angle out, creating a perfect illusion of depth beyond the glass. What's reversed isn't left and right, but front and back. When a surface is polished smooth beyond microscopic imperfections, light remains organized and reflections preserve astonishing detail. Telescopes use enormous mirrors to collect starlight. Microscopes rely on smaller ones to reveal the tiniest structures. Even your bathroom mirror follows the same geometry. Photons leave your face, bounce back instantly, and paint an image that feels almost alive. Engineers refine these reflections even further, crafting multi-layer coatings to control how mirrors behave under different wavelengths. Some built for infrared, others for ultraviolet. These specialized mirrors guide lasers, protect spacecraft, and help scientists peer deeper into both the cosmos and the atom. Reflection, in truth, is not single behavior. It's a spectrum of interactions between light and matter, each revealing or concealing a hidden layer of reality. And finally, polarized light gives.
Light is more than just what we see. It's a hidden language that the natural world uses in astonishing ways. Some creatures use polarized light to uncover secrets invisible to others. They navigate vast landscapes, find water, or send secret signals, all through subtle sky patterns that only they can interpret. Scientists, too, harness polarization to uncover the unseen. By placing stressed plastics or crystals between polarized filters, they reveal intricate, colorful maps of internal tension, patterns of stress that the eye would otherwise miss. Polarization isn't just about brightness or hue. It's another dimension of information that light silently carries, an extra code woven into its waves. And light, remarkable as it is, can even interfere with itself. When two beams of coherent light meet, they don't simply add together, they perform a delicate dance. Where wave crests align, brightness surges. Where crest meets trough, darkness emerges. These rippling interference patterns give us the shimmering rainbows on soap bubbles and oil films, beauty born from microscopic layers bending and splitting light. Nature mastered this trick long before we did. The dazzling colors of peacock feathers or beetle shells come not from pigment, but from structure, tiny architectures that manipulate light through interference. In the lab, this same principle becomes a tool of astonishing precision, capable of detecting changes smaller than the width of an atom. And in the quantum world, even single photons, sent one at a time, can paint interference patterns over time, revealing that light behaves as both particle and wave. Every ripple, every interference pattern is a geometry of paths, a visible signature of light's mysterious journey. Then came one of humankind's most elegant inventions, the laser. Unlike ordinary light, which scatters in every direction, laser light is disciplined, unified, and coherent, a perfect parade of photons marching in step. Inside a laser, energy is stored within atoms or molecules. When a single photon of just the right color passes through, it triggers its neighbors to release identical photons. Mirrors at each end bounce the growing wave back and forth until a narrow, powerful beam escapes, pure, precise, and unwavering. The word laser itself stands for light amplification by stimulated emission of radiation, a phrase that beautifully summarizes the process. Pump energy into a medium, excite its atoms, then let a passing photon spark a cascade of identical copies. This principle, borrowed from radio technology, evolved into something revolutionary, coherent light that could cut steel, heal eyes, and communicate across oceans. Lasers have become the sharp edge of modern precision. In factories, powerful beams slice through metal with surgical focus, melting or vaporizing only what they touch. In hospitals, gentler beams reshape the cornea to restore vision, or seal delicate blood vessels, or remove damaged tissue, all without touching a scalpel. By tuning color, power, and pulse duration, lasers deliver energy exactly where it's needed. The result? Light, transformed into a tool of both craft and care. The very first laser, a ruby red crystal, marked the beginning. In 1960, a flash of light excited chromium atoms inside that synthetic ruby, producing the first coherent beam. It was modest in power, but monumental in impact. From that polished rod of crystal grew entire families of lasers, gas, semiconductor, dye, and fiber, expanding the spectrum of colors and capabilities. From one red spark, a global technology was born. And lasers didn't just cut and heal, they began to hold. Using light as invisible fingers, scientists learned to trap microscopic particles in place. These optical tweezers use focused beams to gently grip transparent objects, moving them with microscopic precision. With them, researchers can hold single cells, stretch DNA molecules, or watch tiny molecular motors at work. Each trapped particle reminds us that photons carry momentum, and that light, though intangible, can push, pull, and control the physical world. At the heart of all this lies the interaction between atoms and light. When a photon strikes an atom, it can lift one of its electrons to a higher energy level. Moments later, that electron falls back, releasing a photon of its own, a rhythm repeated millions of times each second. These rapid exchanges give rise to the steady glow of lamps, flames, and stars. Every element has its own unique fingerprint, specific wavelengths of light it absorbs or emits. Scientists use these patterns, known as spectra, to identify materials on Earth and even analyze the atmospheres of distant planets. The colors in our universe, from neon signs to nebulae, are signatures of electrons leaping between levels, painting the cosmos in light. Even our sun carries a coded message. When its light is spread into a rainbow, dark lines slash across the colors. Each missing wavelength marks an element in the solar atmosphere: hydrogen, helium, and traces of heavier elements. This method, spectroscopy, lets scientists study the sun's chemistry, motion, and temperature without ever touching it. By reading the same spectral patterns in distant stars, astronomers decode their compositions, map their motions, and even detect the subtle gravitational tugs of unseen planets. Light becomes not just illumination, but communication, a messenger from across the cosmos. And sometimes, the message of light is even more dramatic. When a planet passes in front of its star, it blocks a tiny fraction of the starlight, a barely perceptible dimming that repeats in a perfect rhythm. By studying these dips, astronomers measure a planet's size, orbit, and even sniff its atmosphere for water vapor or methane. This transit method has uncovered thousands of worlds, rocky Earth-like planets, blazing giants, and mysterious hybrids, all revealed by faint flickers of starlight. Each pulse, each dimming, whispers of another world waiting in the darkness. That same light also connects our world together. Beneath oceans, bundles of glass fibers carry most of the planet's communication. Within each strand, light ricochets endlessly by total internal reflection, traveling thousands of miles without losing its message. Bits of data, phone calls, videos, research, and memories race as pulses of light through these transparent threads, linking families, markets, and minds across continents. A single strand, thinner than a hair, can carry billions of conversations at once. How? By sending multiple colors of light simultaneously, each acting as its own channel, a technique called wavelength division multiplexing. Optical amplifiers along the way boost all those colors without converting them back into electricity, keeping the signal pure over vast distances. It's silent, cold, and constant, a river of photons flowing beneath the sea, stitching our civilization together with light.
Within every candle flame, a quiet symphony unfolds. Tiny soot particles, heated until they glow, give the familiar golden heart of the flame, while cooler gases at its base shimmer faintly blue. That graceful teardrop of light is alive with movement, combustion, convection, and chemistry performing in perfect harmony. Hot air rises, pulling in fresh oxygen from below, feeding the flame's breath. When the air is still, the flame stands serene and symmetrical. When disturbed, it sways and trembles like a living being seeking air. Each flicker is a visible heartbeat of transformation, carbon and hydrogen meeting oxygen, turning into warmth, light, and invisible trails of vapor drifting upward into night. Moonlight carries its own quiet magic. We think of it as silver, pure and cold, yet true moonlight is full of subtle color, tinted by dust, air, and reflection. The moon's rocky surface scatters sunlight imperfectly, softening it with a faint warmth before sending it back across space. As it passes through Earth's atmosphere, it gathers whispers of blue from snow, gray from water, gold from desert sands, or green from forest leaves. To human eyes, these hues are delicate, almost imagined, but cameras see them clearly. Every moonlit scene is sunlight transformed, not changed in essence, only in tone. It is the same daylight, dressed in the poetry of night. Even the earth itself can paint with lightning, born of fire. During great volcanic eruptions, ash clouds tower into the sky, their particles colliding and charging until the heavens themselves ignite. Bolts flash through plumes of smoke and molten rock, illuminating the eruption like a storm forged from stone. These are not ordinary thunderstorms. They are lightning made from earth and fire, sculpting glowing veins through ash-darkened skies. To watch from afar is to see creation and destruction at once, the planet's rage expressed through light. Scientists study these volcanic tempests to understand how energy moves through matter, but to the soul, they remain visions of raw, untamed beauty, proof that even chaos speaks in light. Far below, in the deepest oceans, other fires bloom, cold, living ones. Some jellyfish drift through black water, pulsing with light of their own making. Inside their transparent bodies, chemistry replaces flame. Oxygen meets luciferin, stirred by an enzyme called luciferase, and out comes a soft, ethereal glow. Some jellyfish pulse slowly, like breathing stars. Others erupt in sudden flares when disturbed, drawing luminous halos around themselves. The light can lure prey, confuse predators, or call to distant mates. From these gentle creatures, scientists discovered proteins that let cells glow under microscopes, transforming deep-sea mystery into modern medicine. Every pulse is a signature of survival and art, proof that even in the ocean's silence, life has found a way to write poetry in light. Along certain shores, entire seas join the performance. Waves break with blue fire that brightens and fades with every swell. Microscopic beings called dinoflagellates create this radiance, producing light whenever the water stirs. A single step into the surf is enough to set them glowing, tiny sparks cascading in liquid motion. The glow startles predators and fascinates humans, turning the ocean into a mirror of the stars. On the darkest nights, whole bays shimmer under this living starlight, each wave a moving constellation. Here, light becomes language, part defense, part wonder, spelled out in glowing tides that remind us that life itself can be luminous. On land, the same language flickers through the air. Fireflies, those tiny lanterns of summer, waste almost no energy when they shine. Inside their bodies, oxygen meets luciferin in perfect efficiency, transforming nearly all energy into light instead of heat. Their rhythmic flashes are both courtship and communication, a love letter written in code across the darkness. Some species synchronize, entire forests pulsing together in waves of gold. Inspired by this perfection, scientists have borrowed their chemistry to create medical tracers and safe glowing materials. The firefly's light is more than romance. It is a lesson in balance, illumination without waste, beauty without excess. In the dark, other eyes borrow the gift of light. When a flashlight catches the gaze of an animal, that eerie reflection is not mystery, it's engineering. Many nocturnal creatures possess a mirror-like layer behind the retina called the tapetum lucidum. It reflects incoming light back through the eye, giving each photon a second chance to be seen. The result? Eyes that can pierce near total darkness. Cats, deer, dogs, and countless others share this silent brilliance, their glinting eyes like ghostly lanterns. The color shifts, green, yellow, white, depending on the species and the angle. That haunting gleam is evolution's way of saying, even the night can be clear. But the light we sense isn't always seen through the eyes. Human skin, too, responds to brightness. Beneath the surface, light-sensitive cells quietly help set the body's internal clock. Even through closed eyelids, daylight signals the brain that morning has come, stirring hormones and resetting rhythms. Blue wavelengths are the most powerful, telling the body it's time to awaken, to align itself with the turning earth. That's why sunlight streaming through curtains can wake us before the alarm ever rings. We don't just see light, we feel it, as our cells tune themselves to the rhythm of day and night. Our eyes, meanwhile, are masters of adjustment. Step from brilliant sunlight into a dim room, and for a heartbeat the world disappears. Then, almost instantly, the pupils widen, the retina resets, and the brain recalibrates reality. Within moments, shapes emerge from shadow. Without this constant adaptation, life would alternate between blindness and glare. Instead, our nervous system performs a miracle every second, balancing brightness and shadow, rewriting perception in real time, ensuring that light never blinds, but always reveals. The sun does more than reveal. It heals. Its rays spark the release of serotonin, the chemical of focus and happiness. It suppresses melatonin to chase away sleepiness and synchronizes the body's rhythm with the passing day. When sunlight fades too early, as in winter, mood and energy can falter. A few minutes outdoors in the morning is often enough to restore balance, to remind the body of its ancient pact with the sun. Every beam that brushes our skin carries not only warmth, but information, aligning our chemistry with the pulse of the planet. But not all light is kind to sleep. The cool glow of phone and laptop screens imitate daylight, especially its blue wavelengths. When we stare at them deep into the night, the brain grows confused, thinking it is still morning. melatonin drops, and rest becomes elusive. Blue light itself isn't harmful, it's essential by day, but at night, its timing is betrayal. That's why modern devices now dim to amber tones after sunset, mimicking firelight instead of noonday sun. The lesson is timeless. Our biology listens to the color of light. To sleep well, we must let night be night. Color itself shapes emotion. Warm light, gold, amber, red, draws us inward, evoking comfort, closeness, and memory. Cool light, blue, silver, green, stirs calm, distance, or melancholy. These responses are ancient, written into both body and culture. Artists and architects use them instinctively. Hospitals bathe rooms in daylight tones to heal. Homes glow in warmer hues to soothe. Light doesn't just reveal, it sculpts feeling, paints time, and directs attention. Every wavelength whispers to the heart. Filmmakers and painters have long understood this silent power. A scene lit with golden tones feels tender, nostalgic, alive with warmth. The same scene washed in cold blue becomes lonely, detached, or ominous. Morning and evening light pass through more atmosphere, softening into gold, while midday light strikes clear and cool. Artists mimic these natural changes to guide emotion, to turn illumination into storytelling. Through color and contrast, they remind us that light is not only seen, but felt.
For light itself, there is no before or after, no ticking of moments between where it begins and where it ends. Each photon we see is an instant connection between 2 points in space-time, a bridge that links source and observer in a single, eternal now. Gravity, however, can bend that perfect path. Einstein revealed that gravity doesn't just tug on planets, it curves the very space through which light moves. When a ray passes near a massive body like a star or galaxy, space-time folds slightly, and light obediently follows the bend. The first proof came during a total solar eclipse, when starlight skimming past the sun appeared displaced from its usual position. In that subtle deflection, humanity saw the universe bow to geometry itself. Across the cosmos, this bending of light creates breathtaking wonders. Enormous clusters of galaxies act as colossal magnifying lenses, bending and focusing light from galaxies hidden far behind them. Through this phenomenon, gravitational lensing, astronomers can glimpse ancient realms otherwise invisible, seeing the faint glow of galaxies born billions of years ago. Sometimes, these cosmic lenses even amplify the light of a single distant star, making it briefly outshine entire galaxies. By tracing these distortions, scientists can also map the unseen presence of dark matter, whose invisible weight shapes the very architecture of the cosmos. Yet gravity's grasp grows most dramatic at the edge of black holes. Near their event horizons, light itself begins to struggle. Photons claw their way outward, losing energy and stretching into longer wavelengths until they fade into invisibility. To us, it looks as though light slows and freezes on the edge of eternity, its last message stretched across infinity by the warping of space-time. The light that escapes carries with it the faint whisper of matter's final moments before it falls forever into the dark. Closer still lies the photon sphere, a ring-shaped boundary where light bends into perfect circles. Here, photons can orbit endlessly, caught between freedom and capture. Though unstable, this zone creates the glowing halo we see in real images of black holes, the famous ring of fire, born from light looping countless times before escaping toward Earth.
These glowing edges allow scientists to measure the mass and spin of black holes, turning trapped light into the universe's most extreme measuring tool. That first moment of proof, starlight bending around the sun, transformed science itself. During that 1919 eclipse, Einstein's prediction became reality. Photographs revealed background stars slightly shifted, exactly as he had foreseen. In that instant, gravity was no longer just a force, it became the shape of space itself. Every observation of gravitational lensing today is an echo of that moment when the cosmos first confirmed one of humanity's most daring ideas. But light is not always delicate, it can roar. Quasars, for instance, shine brighter than entire galaxies. Each one is powered by a supermassive black hole devouring matter at the heart of a young galaxy. As the gas spirals inward, friction and magnetic fury heat it to millions of degrees, unleashing torrents of light and radiation so intense that a single quasar can outshine 100 billion stars. They are cosmic lighthouses from the dawn of time, revealing how galaxies form, evolve, and collide. And sometimes the universe screams in flashes that outshine everything else. The gamma ray bursts. These are the most powerful explosions ever observed, erupting when massive stars collapse or when neutron stars merge. In seconds, they release more energy than our sun will emit in its entire lifetime. Detectors in orbit record them as blinding bursts that fade swiftly, but their afterglows tell stories of unimaginable violence, the kind that forges heavy elements and reshapes galaxies. These bursts are cosmic shouts of creation and destruction, where gravity's fury becomes radiant beauty. Every atom that burns in those distant furnaces carries its own unique signature of light, a kind of cosmic barcode. Each element absorbs and emits photons at precise wavelengths, forming patterns that identify its presence. Through spectroscopy, scientists can analyze starlight and determine what the stars are made of, how fast they move, even how far away they are. Without ever leaving Earth, we can read the universe's composition simply by decoding its light. Across the cosmos, from stellar cores to intergalactic clouds, every element signs its name in this universal language. But light also tells stories closer to home, some beautiful, others tragic. In the early 1900s, glowing watch dials were painted with radium, a new wonder of science. The soft greenish glow felt magical, but it came with a deadly secret. The workers, many young women who painted those luminous numbers, were slowly poisoned by radiation. Their suffering exposed the dangers of radioactivity and forever changed workplace safety and medical research. Today, our glowing watches and emergency signs shine harmlessly, powered by safe phosphorescent compounds. The gentle glow now honors those who once paid the price for progress. The transformation of invisible energy into visible light continues in everyday miracles. In fluorescent lamps, electricity excites gas molecules to emit ultraviolet rays, which then strike a phosphor coating inside the glass tube. That coating converts invisible radiation into bright, efficient light. The same principle animates minerals that glow under UV light and deep-sea creatures that shimmer in the darkness. Each flicker of a fluorescent lamp is a small reminder that energy can change its form, bridging the unseen and the visible. And then came LEDs, tiny crystals that revolutionized illumination. Inside them, electrons leap across atomic barriers, releasing photons with astonishing efficiency. By adjusting the materials, engineers can tune their color from warm amber to cool white. LEDs waste almost no energy, last for decades, and now light everything from street lamps to smartphone screens.
Each one is a microscopic factory where electricity becomes light with precision and grace. And finally, even the humble candle carries the same dance of physics. Its steady flame appears calm, yet inside it, air currents swirl and twist, feeding the fire unevenly. Each invisible gust shifts the flame's shape, making it flicker, flare, and dim in delicate rhythm. That tiny dance of light, born from chemistry and air, mirrors the restless beauty of the cosmos itself, a reminder that every flicker, from a candle to a quasar, is light telling its eternal story.
Within every candle flame, a quiet symphony unfolds. Tiny soot particles, heated until they glow, give the familiar golden heart of the flame, while cooler gases at its base shimmer faintly blue. That graceful teardrop of light is alive with movement, combustion, convection, and chemistry performing in perfect harmony. Hot air rises, pulling in fresh oxygen from below, feeding the flame's breath. When the air is still, the flame stands serene and symmetrical. When disturbed, it sways and trembles like a living being seeking air. Each flicker is a visible heartbeat of transformation. Carbon and hydrogen meeting oxygen, turning into warmth, light, and invisible trails of vapor drifting upward into night. Moonlight carries its own quiet magic. We think of it as silver, pure and cold, yet true moonlight is full of subtle color, tinted by dust, air, and reflection. The moon's rocky surface scatters sunlight imperfectly, softening it with a faint warmth before sending it back across space. As it passes through Earth's atmosphere, it gathers whispers of blue from snow, gray from water, gold from desert sands, or green from forest leaves. To human eyes, these hues are delicate, almost imagined, but cameras see them clearly. Every moonlit scene is sunlight transformed, not changed in essence, only in tone. It is the same daylight, dressed in the poetry of night. Even the earth itself can paint with lightning, born of fire. During great volcanic eruptions, ash clouds tower into the sky, their particles colliding and charging until the heavens themselves ignite. Bolts flash through plumes of smoke and molten rock, illuminating the eruption like a storm forged from stone. These are not ordinary thunderstorms. They are lightning made from earth and fire, sculpting glowing veins through ash-darkened skies. To watch from afar is to see creation and destruction at once, the planet's rage expressed through light. Scientists study these volcanic tempests to understand how energy moves through matter, but to the soul, they remain visions of raw, untamed beauty, proof that even chaos speaks in light. Far below, in the deepest oceans, other fires bloom, cold, living ones. Some jellyfish drift through black water, pulsing with light of their own making. Inside their transparent bodies, chemistry replaces flame. Oxygen meets luciferin, stirred by an enzyme called luciferase, and out comes a soft, ethereal glow. Some jellyfish pulse slowly, like breathing stars. Others erupt in sudden flares when disturbed, drawing luminous halos around themselves. The light can lure prey, confuse predators, or call to distant mates. From these gentle creatures, scientists discovered proteins that let cells glow under microscopes, transforming deep-sea mystery into modern medicine. Every pulse is a signature of survival and art, proof that even in the ocean's silence, life has found a way to write poetry in light. Along certain shores, entire seas join the performance. Waves break with blue fire that brightens and fades with every swell. Microscopic beings called dinoflagellates create this radiance, producing light whenever the water stirs. A single step into the surf is enough to set them glowing, tiny sparks cascading in liquid motion. The glow startles predators and fascinates humans, turning the ocean into a mirror of the stars. On the darkest nights, Whole bays shimmer under this living starlight, each wave a moving constellation. Here, light becomes language, part defense, part wonder, spelled out in glowing tides that remind us that life itself can be luminous. On land, the same language flickers through the air. Fireflies, those tiny lanterns of summer, waste almost no energy when they shine. Inside their bodies, oxygen meets luciferin in perfect efficiency, transforming nearly all energy into light instead of heat. Their rhythmic flashes are both courtship and communication, a love letter written in code across the darkness. Some species synchronize, entire forests pulsing together in waves of gold. Inspired by this perfection, scientists have borrowed their chemistry to create medical tracers and safe glowing materials. The firefly's light is more than romance. It is a lesson in balance, illumination without waste, beauty without excess. In the dark, other eyes borrow the gift of light. When a flashlight catches the gaze of an animal, that eerie reflection is not mystery, it's engineering. Many nocturnal creatures possess a mirror-like layer behind the retina called the tapetum lucidum. It reflects incoming light back through the eye, giving each photon a second chance to be seen. The result? Eyes that can pierce near total darkness. Cats, deer, dogs, and countless others share this silent brilliance, their glinting eyes like ghostly lanterns. The color shifts, green, yellow, white, depending on the species and the angle. That haunting gleam is evolution's way of saying, even the night can be clear. But the light we sense isn't always seen through the eyes. Human skin, too, responds to brightness. Beneath the surface, light-sensitive cells quietly help set the body's internal clock. Even through closed eyelids, daylight signals the brain that morning has come, stirring hormones and resetting rhythms. Blue wavelengths are the most powerful, telling the body it's time to awaken, to align itself with the turning earth. That's why sunlight streaming through curtains can wake us before the alarm ever rings. We don't just see light, we feel it, as our cells tune themselves to the rhythm of day and night. Our eyes, meanwhile, are masters of adjustment. Step from brilliant sunlight into a dim room, and for a heartbeat the world disappears. Then, almost instantly, the pupils widen, the retina resets, and the brain recalibrates reality. Within moments, shapes emerge from shadow. Without this constant adaptation, life would alternate between blindness and glare. Instead, our nervous system performs a miracle every second, balancing brightness and shadow, rewriting perception in real time, ensuring that light never blinds, but always reveals. The sun does more than reveal. It heals. Its rays spark the release of serotonin, the chemical of focus and happiness. It suppresses melatonin to chase away sleepiness and synchronizes the body's rhythm with the passing day. When sunlight fades too early, as in winter, mood and energy can falter. A few minutes outdoors in the morning is often enough to restore balance, to remind the body of its ancient pact with the sun. Every beam that brushes our skin carries not only warmth, but information, aligning our chemistry with the pulse of the planet. But not all light is kind to sleep. The cool glow of phone and laptop screens imitate daylight, especially its blue wavelengths. When we stare at them deep into the night, the brain grows confused, thinking it is still morning. Melatonin drops, and rest becomes elusive. Blue light itself isn't harmful, it's essential by day, but at night, its timing is betrayal. That's why modern devices now dim to amber tones after sunset, mimicking firelight instead of noonday sun. The lesson is timeless. Our biology listens to the color of light. To sleep well, we must let night be night. Color itself shapes emotion. Warm light, gold, amber, red, draws us inward, evoking comfort,
closeness, and memory. Cool light, blue, silver, green, stirs calm, distance, or melancholy. These responses are ancient, written into both body and culture. Artists and architects use them instinctively. Hospitals bathe rooms in daylight tones to heal. Homes glow in warmer hues to soothe. Light doesn't just reveal, it sculpts feeling, paints time, and directs attention. Every wavelength whispers to the heart. Filmmakers and painters have long understood this silent power. A scene lit with golden tones feels tender, nostalgic, alive with warmth. The same scene washed in cold blue becomes lonely, detached, or ominous. Morning and evening light pass through more atmosphere, softening into gold, while midday light strikes clear and cool. Artists mimic these natural changes to guide emotion, to turn illumination into storytelling. Through color and contrast, they remind us that light is not only seen, but felt, carrying the emotional temperature of every moment we live and remember.
Light is emotion made visible. A silent artist capable of shaping space into feeling and time into memory. Yet, as our cities glow brighter each night, that same light begins to steal something precious. Across urban skies, street lamps, neon signs, and glowing windows weave a dome of brightness that drowns the stars. This artificial haze, called sky glow, scatters off dust and moisture until only the boldest stars remain visible. The loss is more than beauty, it is ecological. Birds, turtles, and countless nocturnal creatures lose their bearings, their ancient maps erased by our glow. But the darkness can be restored. By shielding lamps to direct light downward and choosing warmer, softer hues that scatter less, cities can reclaim the night. When this happens, constellations return and the Milky Way once again stretches across the sky, so bright it can cast faint shadows. The stars were never gone, they were merely waiting for us to turn off the lights and look up again. Astronomers, the great interpreters of light, use filters to reveal the hidden worlds within it. Through their telescopes, they separate light into its many voices, isolating hydrogen's crimson whisper, oxygen's cool breath, and sulfur's ghostly glow. By combining these filtered views, they expose nebulae, shock waves, and star nurseries invisible to the naked eye. What appears as black emptiness becomes a symphony of color and motion. These filters remind us that light is never one story, but countless overlapping tales waiting to be read in different wavelengths. In the quiet world of plants, light writes another kind of story, one of motion and purpose. Watch a stem turn toward a window, and you're witnessing phototropism, the plant's elegant dance toward its source of life. On the shaded side, hormones called auxins gather, urging cells to stretch and push the stem toward illumination. It's a graceful choreography, ensuring that every leaf can drink in the sun. Roots, guided instead by gravity, follow a darker path downward. Even tiny seedlings buried in soil wait attentively for the first hint of light, poised to awaken at the perfect moment. Before it even sprouts, a seed can sense light. Hidden within its shell, photoreceptor molecules detect the balance between red and far-red wavelengths, signals that reveal whether it lies in shadow or sunlight. Only when those cues align does it begin to grow. Farmers use this secret language of light to synchronize crops, while forests filter it naturally, shaping where life begins. In that small, waiting seed lies wisdom, a quiet patience that listens for the sun before writing the first line of its story.
When the plant finally awakens, sunlight becomes food, air, and breath. Through photosynthesis, green leaves perform one of the most extraordinary transformations in the cosmos. They turn photons into life. Within each chloroplast, chlorophyll captures light and splits water, freeing oxygen and forging sugars from carbon dioxide. From this reaction flows nearly every heartbeat and breath on Earth. The food we eat, the air we breathe, even the fuel that drives our engines, all are echoes of ancient sunlight stored in matter. Every forest, field, and blade of grass is a living solar panel, quietly converting radiance into existence. Light's touch reaches far beyond Earth. Even faint starlight can push a spacecraft forward. Though photons have no mass, they carry momentum, and when they strike a surface, they deliver a delicate, constant pressure. Over time, this whisper of force can shift or steer a craft across the void. Engineers harness it with reflective panels, adjusting angles to ride sunlight like an invisible current. The same principle shapes the glowing tails of comets and the drifting of cosmic dust, a reminder that even in emptiness, light has the power to move worlds. From this idea comes one of humanity's most poetic technologies, the solar sail. Imagine a spacecraft gliding silently through the dark, powered not by fuel, but by sunlight itself. Vast mirrored sheets catch photons like a cosmic breeze, each one imparting a tiny push. Though the acceleration is gentle, it never stops. Over weeks and months, the craft gathers speed, sailing through space on a wind made of light. It's a return to our oldest instincts, trading ocean currents for starlit ones, where the sun becomes both compass and engine, carrying our curiosity into the infinite. And yet, even with all our inventions, the generosity of the sun still humbles us. In just 1 hour, the energy it sends to Earth exceeds everything humanity consumes in an entire year. Most of this vast gift warms oceans, drives winds, and powers photosynthesis. Only a small portion is harnessed by our technology, and yet even that fraction could change civilization. The sun's bounty dwarfs every fire we've ever kindled, a silent reminder that the universe provides more than enough if we learn to listen to its light. But when focused, however, that same light can transform from nurturing to destructive. Ancient civilizations learned that curved mirrors or polished stones could concentrate sunlight to a searing point, hot enough to ignite fires or melt metal. Today, solar furnaces use the same principle, directing thousands of mirrors toward a single tower to generate immense heat and energy. At the focus of that beam, light becomes nearly divine, capable of creating or destroying with equal grace. A small shift disperses it harmlessly again, returning it to warmth and glow. Long before modern science, ancient priests used this sacred fire as ritual, igniting flames with quartz or bronze to symbolize divine light descending from the heavens. Across Greece, Egypt, and the Americas, sunlight was both tool and deity, the bridge between the mortal and the eternal. Those same principles later gave rise to lenses and telescopes, the instruments that would let us study the stars once thought to be gods. Every flame sparked from a polished stone was a union of reverence and reason, the beginning of humankind's long conversation with light. The ancients also looked upward and began to measure the heavens. Long before telescopes, the Greek astronomer Hipparchus charted the brightness of stars, dividing them into 6 magnitudes from brightest to faintest. That ancient system, refined but still recognizable, remains the foundation of modern astronomy. Today, instruments measure variations in starlight billions of times subtler than the human eye could ever detect. Brightness has become not just a measure of visibility, but of distance, temperature, and power, each flicker a clue to the nature of the cosmos. Across millennia, the stars themselves have not changed, only our way of understanding them has deepened. And even now, light keeps revealing new secrets. Every photon carries not just energy, but a delicate spin, a tiny twist of angular momentum. This invisible spin, called spin angular momentum, allows scientists to rotate microscopic objects, trap atoms, and explore quantum frontiers. Light, it turns out, doesn't just travel, it dances, its wave fronts twisting like ribbons through space. Each beam, no matter how straight, carries within it a spiral, a quiet, graceful spin that mirrors the universe's own rhythm. And through that rhythm, light whispers its final wonder: connection. Quantum entanglement binds photons across unimaginable distances, proving that even in separation, there can be unity, a thread of light tying the cosmos together.
When two photons are born together in a special quantum process, they can become entangled, bound by an invisible thread that keeps their properties linked, no matter how far they drift apart. Measure one, and the other responds instantly, as if they still whisper across the gulf of space. Experiments have proven this eerie connection over vast distances, revealing that quantum information transcends classical boundaries. Though it cannot send messages faster than light, it lays the foundation for quantum encryption and teleportation. In a way, entangled photons are partners in a cosmic dance, two sparks forever synchronized by their shared beginning. They remind us that light isn't just a traveler through space, it's part of a deeper, interconnected fabric of reality. Every entangled pair is a quiet reminder that the universe is woven not only from matter and motion, but from relationships written in light itself. Scientists have even managed to teleport information between linked photons, transferring the state of one to another across distance without moving a single particle. This process, known as quantum teleportation, doesn't send the photon itself, but rather the information that defines it, carried through their shared entanglement. It's a delicate operation, demanding extraordinary precision and near-perfect isolation from noise, yet it's been repeated many times in labs around the world. Each success brings us closer to a future where information travels not on wires or waves, but on the quantum fabric of reality itself. What once lived only in science fiction now flickers in real experiments, proof that light can bridge not just distance, but dimensions of understanding. The future of communication, it seems, is being written in photons. Our eyes, too, have their own harmony with light. In daylight, the human eye is most sensitive to green, tuned by evolution to the sun's natural spectrum. Our cone cells, shaped by millions of years beneath this star, respond strongest to these mid-range wavelengths, giving us clarity, color, and depth under the sun's glow. At night, rod cells take over, shifting toward blues and grays as colors fade into shadow. Artists and photographers understand this instinctively, using soft greens to suggest brightness without glare. When you look over a sunlit meadow, you're seeing more than color. You're witnessing a partnership between the eye and the sun, vision tuned perfectly to its native star. When fog rolls in, red light endures. Shorter blue wavelengths scatter easily, while the longer red waves push through haze and dust. That's why brake lights, warning beacons, and sunsets all burn crimson through thick air. Even distant stars take on a reddish hue when viewed through cosmic dust. Red is the survivor, the steadfast color that cuts through confusion, guiding travelers safely home.
Nature, too, knows the secret. Deep-sea creatures cloak themselves in red, a color that vanishes in the ocean's depths, making them invisible in their twilight world. Whether in air or water, the behavior of light defines what can be seen and what must remain unseen. On cloudy days, light becomes soft and forgiving. The sun's sharp edges dissolve, shadows blur, and color spreads evenly across the world. Clouds act as vast diffusers, scattering light in every direction. The result is calm illumination, gentle, balanced, kind. Photographers treasure this light. Nature thrives in it. It soothes plants and animals alike, tempering the extremes of brilliance and darkness. Architects mimic this softness with translucent walls and reflective surfaces, letting rooms glow with sky-colored calm. Under such light, everything seems truer, quieter, revealed without glare, hidden without loss, as if the world itself takes a deep breath. During an eclipse, the sun's hidden crown, the corona, becomes visible. As the moon drifts across the solar face, the day dims, and from behind the darkness blooms a silver fire. The corona, woven by magnetic fields, stretches far into space, ghostly and radiant. For a few fleeting minutes, the sun reveals its secret architecture of plasma and magnetism. It's a reminder that even in overwhelming brightness, there are gentler lights waiting to be seen once the glare is gone. Beyond all stars lies a faint cosmic glow, the collective shimmer of every galaxy that has ever existed. This ancient background light is unimaginably soft, yet it fills all of space. Each photon is a trace from some forgotten sun, a whisper from a star long dead. It's the quiet memory of creation itself, the soft hum of starlight on a universal scale. When we gaze into the dark between constellations, we are not looking into emptiness, but into the lingering breath of everything that has ever shone. Deep inside the hearts of stars, neutrinos are born beside photons, ghostly particles that pass through entire planets without pause. While light may take thousands of years to escape a star's core, neutrinos slip free instantly, carrying messages from the nuclear fires within. Detectors hidden deep beneath Earth record their faint arrival, glimpsing the secrets of stars through these silent messengers. Every beam of sunlight that touches your skin travels beside an invisible stream of neutrinos, unseen, unstoppable, eternal. In the beginning, before the universe grew transparent, there was only radiant fog. Light could not travel. It was trapped, scattered endlessly among charged particles. Then came cooling, expansion, and the first atoms, and at last, light was free. That first glow still fills the cosmos today as the cosmic microwave background, the afterglow of creation itself. When scientists map it, they are looking at the oldest possible image, the first dawn when darkness itself was born. Even the darkest space is never truly empty. It hums softly with the residue of that ancient light, stretched thin by time and distance. The universe still glows, quietly, with the memory of its own birth. What we call emptiness is simply light at rest, the faint echo of everything that has ever been. Every photon that travels carries a memory. Its color, its angle, its vibration, each tells the story of where it came from and what it touched. When it finally meets your eye or a telescope's lens, that message is delivered, a story written across the fabric of time. Light is the universe's storyteller. It never stops moving, never stops remembering. It shaped stars, traced galaxies, and painted the first dawn across a silent Earth. Every ray that warms your skin began its journey long before you existed, crossing eternity,
just to arrive here, now. It glides through leaves, ripples over oceans, and finds reflection in your heartbeat. The glow outside your window tonight may have been born in a star that died before language began, and yet it arrives, endlessly, faithfully, binding your life to the cosmos beyond. Wherever it travels, light remembers. It carries the fingerprints of atoms, the songs of stars, the echoes of beginnings that never truly ended. Even in darkness, it never disappears. It only waits, resting, ready to shine again. So, as your thoughts drift toward sleep, imagine that same quiet radiance within you, the warmth in your chest, the soft glow behind your eyes, the still rhythm of your breath. All of it is light, gathered briefly into human form. You are not apart from the universe that shines. You are part of its light, fleeting, gentle, eternal. If this journey through light has brought you peace, I invite you to like, subscribe, and share your thoughts below. It helps others find their way to this quiet corner of the cosmos, one sleepy soul at a time. Now breathe. Let your eyes grow heavy, and let the light cradle you, infinite, patient, and kind.
In a way, entangled photons are partners in a cosmic dance, two sparks forever synchronized by their shared beginning. They remind us that light isn't just a traveler through space, it's part of a deeper, interconnected fabric of reality. Every entangled pair is a quiet reminder that the universe is woven not only from matter and motion, but from relationships written in light itself. Scientists have even managed to teleport information between linked photons, transferring the state of one to another across distance without moving a single particle. This process, known as quantum teleportation, doesn't send the photon itself, but rather the information that defines it, carried through their shared entanglement. It's a delicate operation, demanding extraordinary precision and near-perfect isolation from noise, yet it's been repeated many times in labs around the world. Each success brings us closer to a future where information travels not on wires or waves, but on the quantum fabric of reality itself. What once lived only in science fiction now flickers in real experiments, proof that light can bridge not just distance, but dimensions of understanding. The future of communication, it seems, is being written in photons. Our eyes, too, have their own harmony with light. In daylight, the human eye is most sensitive to green, tuned by evolution to the sun's natural spectrum. Our cone cells, shaped by millions of years beneath this star, respond strongest to these mid-range wavelengths, giving us clarity, color, and depth under the sun's glow. At night, rod cells take over, shifting toward blues and grays as colors fade into shadow. Artists and photographers understand this instinctively, using soft greens to suggest brightness without glare. When you look over a sunlit meadow, you're seeing more than color. You're witnessing a partnership between the eye and the sun, vision tuned perfectly to its native star. When fog rolls in, red light endures. Shorter blue wavelengths scatter easily, while the longer red waves push through haze and dust. That's why brake lights, warning beacons, and sunsets all burn crimson through thick air. Even distant stars take on a reddish hue when viewed through cosmic dust. Red is the survivor, the steadfast color that cuts through confusion, guiding travelers safely home. Nature, too, knows the secret. Deep-sea creatures cloak themselves in red, a color that vanishes in the ocean's depths, making them invisible in their twilight world. Whether in air or water, the behavior of light defines what can be seen and what must remain unseen.
On cloudy days, light becomes soft and forgiving. The sun's sharp edges dissolve, shadows blur, and color spreads evenly across the world. Clouds act as vast diffusers, scattering light in every direction. The result is calm illumination, gentle, balanced, kind. Photographers treasure this light. Nature thrives in it. It soothes plants and animals alike, tempering the extremes of brilliance and darkness. Architects mimic this softness with translucent walls and reflective surfaces, letting rooms glow with sky-colored calm. Under such light, everything seems truer, quieter, revealed without glare, hidden without loss, as if the world itself takes a deep breath. During an eclipse, the sun's hidden crown, the corona, becomes visible. As the moon drifts across the solar face, the day dims, and from behind the darkness blooms a silver fire. The corona, woven by magnetic fields, stretches far into space, ghostly and radiant. For a few fleeting minutes, the sun reveals its secret architecture of plasma and magnetism. It's a reminder that even in overwhelming brightness, there are gentler lights waiting to be seen once the glare is gone. Beyond all stars lies a faint cosmic glow, the collective shimmer of every galaxy that has ever existed. This ancient background light is unimaginably soft, yet it fills all of space. Each photon is a trace from some forgotten sun, a whisper from a star long dead. It's the quiet memory of creation itself, the soft hum of starlight on a universal scale. When we gaze into the dark between constellations, we are not looking into emptiness, but into the lingering breath of everything that has ever shone. Deep inside the hearts of stars, neutrinos are born beside photons, ghostly particles that pass through entire planets without pause. While light may take thousands of years to escape a star's core, neutrinos slip free instantly, carrying messages from the nuclear fires within. Detectors hidden deep beneath Earth record their faint arrival, glimpsing the secrets of stars through these silent messengers. Every beam of sunlight that touches your skin travels beside an invisible stream of neutrinos, unseen, unstoppable, eternal. In the beginning, before the universe grew transparent, there was only radiant fog. Light could not travel. It was trapped, scattered endlessly among charged particles. Then came cooling, expansion, and the first atoms, and at last, light was free. That first glow still fills the cosmos today as the cosmic microwave background, the afterglow of creation itself. When scientists map it, they are looking at the oldest possible image, the first dawn when darkness itself was born. Even the darkest space is never truly empty. It hums softly with the residue of that ancient light, stretched thin by time and distance. The universe still glows, quietly, with the memory of its own birth. What we call emptiness is simply light at rest, the faint echo of everything that has ever been. Every photon that travels carries a memory. Its color, its angle, its vibration, each tells the story of where it came from and what it touched. When it finally meets your eye or a telescope's lens, that message is delivered, a story written across the fabric of time. Light is the universe's storyteller. It never stops moving, never stops remembering. It shaped stars, traced galaxies, and painted the first dawn across a silent Earth. Every ray that warms your skin began its journey long before you existed, crossing eternity just to arrive here, now. It glides through leaves, ripples over oceans, and finds reflection in your heartbeat. The glow outside your window tonight may have been born in a star that died before language began, and yet it arrives, endlessly, faithfully, binding your life to the cosmos beyond. Wherever it travels, light remembers. It carries the fingerprints of atoms, the songs of stars, the echoes of beginnings that never truly ended. Even in darkness, it never disappears. It only waits, resting, ready to shine again. So, as your thoughts drift toward sleep, imagine that same quiet radiance within you, the warmth in your chest, the soft glow behind your eyes, the still rhythm of your breath. All of it is light, gathered briefly into human form. You are not apart from the universe that shines. You are part of its light, fleeting, gentle, eternal. If this journey through light has brought you peace, I invite you to like, subscribe, and share your thoughts below. It helps others find their way to this quiet corner of the cosmos, one sleepy soul at a time. Now breathe. Let your eyes grow heavy, and let the light cradle you, infinite, patient, and kind. Good night.